Who knew that you could discover millions of new materials with deep learning? So Google DeepMind have come up with something known as graph networks for material exploration. Their new deep learning tool, which dramatically increases the speed and efficiency of discovery by predicting the stability of new materials. So they share the discovery of 2.2 million new crystals, which is equivalent to 800 years worth of knowledge. So this tool finds 2.2 million new crystals, right? So all your modern technologies, computer chips and batteries rely on inorganic crystals. And to enable new technologies, crystals must be stable. Otherwise, they can decompose. And behind each new stable crystal can be months of painstaking experimentation. Now, this is what has been improved with this particular graph networks for material exploration. So, they have multiplied the number of technology viable materials known to humanity. And they are saying that out of 2.2 million predictions, 380k are the most stable, right? Making them promising candidates for experimental synthesis. And the best part is that out of this 380k, already various labs, okay, external researchers in various labs have independently created 736 of these new structures, okay, experimentally in concurrent work, right? And in partnership with Google DeepMind, there is this Berkeley National Laboratory, Lawrence Berkeley National Laboratory. They have also synthesized these materials. Okay, this is a huge development for material science, right? They are saying that about previously, 50,000 new layered compounds similar to graphene has been identified. Previously, only about 100 such materials had been identified. Okay, but now they have found 52k new compounds which are similar to graphene. They have also found 528 potential lithium ion conductors, 25 times more than the previous study, right, which could be used to improve the performance of rechargeable batteries, right? So this is a huge development. And what is behind this development? So this particular network called GNoME, okay, this is based, it's a graph neural network. It consists of two pipelines to discover low energy or stable materials. One is a structural pipeline which creates candidates similar to known crystals. Okay, there is a compositional pipeline. Compositional pipeline follows a more randomized approach based on chemical formulas. The output of both pipelines are evaluated using a established density functional theory calculations, and the results are added to the GNoME database. And this informs the next round of active learning. So they're using active learning over here and graph neural networks. So this is a state-of-art graph neural network. Basically, the input data for graph neural network takes form of a graph, and here you can consider it to be the connections between atoms. This makes graph neural networks particularly suited to discovering new crystalline materials. The crystalline material chemical composition can be represented as graphs, right? So basically, this graph neural network comes up with new chemical compositions. Okay, that is the idea over here. Okay. So, and another thing is that they are saying that rapidly developing new technologies based on these crystals will depend on the ability to manufacture them. Okay. So, in a paper led by their collaborators at Berkeley Lab, researchers showed a robotic lab that could rapidly make new materials with automated synthesis technique. Using materials from the materials project and insights on the stability from GNoME, this autonomous lab created 41 new materials, opening up new possibilities for AI-driven material synthesis. So you already have results also, okay, of the materials which have been predicted by this particular model. Already they had 736 of these independently developed, as well as these new 41 new materials which have been developed by the Berkeley lab. Okay, so they have robots which can develop these materials. Okay. So A Lab is a facility at Berkeley Lab where artificial intelligence guides robots in making new materials. Right. So this is an exciting development in the material space. Right. People working in the domain would know the difficulty of coming up with new materials. Now with this tool, they can actually develop new materials much more faster. Okay. And with newer technologies coming for manufacturing these materials, I think in the future we will see more and more new materials coming up, and these would have wide variety of use cases. So this is a short video on GNoME from Google Deepmind, where millions of new materials were discovered with deep learning. I hope you like this video. I'll be putting this blog in the description of the video. They also have a paper. You can check it out. If you like the video, please like, share, subscribe to the channel. See you in a new video.